How do design patterns avoid null pointer exceptions? Imagine you're building a house and every time you want to turn on a light, you first check if the switch exists. If it doesn't, you might get an electric shock or the light just won't turn on. In programming, this is similar to null pointer exceptions. They happen when you try to use an object that doesn't exist or is null. Now, how can you prevent these surprises from happening? That's where design patterns come into play. They give you smart ways to handle situations where objects might be missing, so your program keeps running smoothly. One of the most popular ways is called the null object pattern. Think of it like having a dummy switch that looks like a real switch but does nothing. Instead of checking if the switch exists every time, you just use this dummy switch. It responds safely to your commands without causing errors. This pattern creates a special object that follows the same rules as real objects but has default or empty behaviors. So, when your code calls a method on this null object, it just does nothing or returns a safe value, avoiding crashes. To set this up, you start with an interface or an abstract class that lists all the methods your object should have. Then, you create a real class that does the actual work, and a null object class that implements the same interface but with empty methods. When your program needs an object, instead of returning null, it returns a null object. This way, your code can call methods without worrying about null checks. Besides the null object pattern, there are other ways to dodge null pointer exceptions. For example, in Java 8 and later, you can use the optional class. It wraps a value that might be missing and forces you to check if it's there before using it. You can also use conditional checks or ternary operators to verify if an object is null before calling its methods. These techniques are useful in many scenarios. For instance, in logging systems, instead of checking if a logger exists, you can use a null logger that does nothing. In graphical user interface frameworks, null components act as placeholders that do nothing but keep the program running. Collections can return null iterators instead of null, so loops don't break. Using design patterns like the null object pattern makes your code safer and easier to debug. It reduces the need for repeated null checks, which can clutter your code and hide bugs. Instead, your code becomes more predictable because objects behave consistently, even when they are meant to do nothing. This approach helps you catch bugs faster and makes fixing issues less frustrating. So, in simple terms, design patterns avoid null pointer exceptions by replacing null references with objects that respond safely to method calls. This keeps your program running smoothly and makes debugging less of a headache. It's a smart way to write more reliable code and avoid those pesky runtime errors that can stop your program in its tracks.